So in this tutorial, we'll be talking about error handling in Python. So we need to actually know how to actually handle errors. Okay, there are mainly two types of errors: syntax errors and exceptions. So syntax errors occur when you actually type the wrong syntax. So the predefined keywords and the predefined things in Python, they all have syntaxes. So for example, print print should have this print statement followed by this open and close braces, and only inside quotes only you can actually type something. So if you, for example, add an extra braces here, this is actually a syntax error. You can see that is actually a syntax error because we added an extra braces here. So that is not possible because we have to follow the Python syntax here. So these are called syntax errors when you sometimes add an extra colon or an extra braces, and Python raises a syntax error. Syntax errors are much easier to solve because you know the Python syntax and you can easily solve them. The next type of errors are exceptions. So for example, I say a is equal to 5 plus a string here, maybe hello, and if I try to print a, we'll get an error saying type error unsupported operand. We cannot add an indent string together, so we get a type error here. So that is the type error. We get this when we try to add an indenter for an example. So we also have other errors. For example, I'll say import module or something, some module that doesn't exist, and if I run the program, you can see another error saying module not found error. This is actually an exception saying that no such module exists. So we also have other errors like name error. For example, I'll say a is equal to b or a is equal to 1, and I'll say b is equal to c. Now if I just simply run this program, we get a name error actually saying that C is not defined, so we have not defined what C is here, so it's actually name error. And then we have a lot of exceptions. So another thing I would like to show you is the file not found error. For example, I'll open a file here, so I'll say with open, and let's try to open a file that doesn't exist. I'll say no file dot text. Actually this is a file name and I'm sure that it doesn't exist, and we have to specify read mode here, and I'll say as file. So now, and if I say pass here, and if I just run this program, you'll get the file not found error because no because no such file or directory exists, so it cannot be opened. Then we have the value error. So to show the value error, let me just declare a list here with a 1, 2 and 3, and now if I say print a of 4, I'll get an index error. So because it is out of range, so here we only have 0, 1 and 2. So two indexes, two elements is 3 elements in total. So here I'm trying to access the fifth element of index 4, and that doesn't really exist, so we get an index error. Now if I just try to remove an element or add an element, I mean if I try to remove an element that doesn't exist, I get another error called value error because it doesn't exist. So these are all different types of exceptions, uh, and one final exception that I would like to show you is something inside a dictionary. So we'll say dictionary is equal to, and I'll just create a sample dictionary. I'll say name is Jack. So now if I say print dictionary of age. We have actually seen this error before. This is actually a key error when you try to access an item inside a dictionary that doesn't exist. So it gives out a key error. So now we can actually raise our own error, I mean our own exceptions. So for example, say I have a variable with value 10. I can manually actually raise an exception here. If I say if a is greater than, or if a is less than 15, then I can use the raise keyword to actually raise a manual error. So I can say raise exception, and inside the braces we have to specify the error message that we have to print. So here simply we'll say error uh, value less than 15. So yeah, now if I just run the program, we get an exception here with the message that we actually printed here. Error value is less than 50. So now if I just change this to maybe 17 and rerun the program, now if I rerun the program, you can see that that exception is removed. So if I change this again and run this, we get the same error. This is actually this is the exception that we declared here. So we can also use the assert keyword here. So if I just remove this and I'll say assert, and assert, and after that inside braces you have to say 10 or a should be greater than 15. So now if I run this program, you'll get an assertion error. We are actually saying, or we are actually forcing and saying that a should be greater than 15, but it is not. So we get an assertion error here. Okay, so now we actually saw different types of errors and exceptions that we can actually encounter in a real program. So now let's see how to actually handle these errors, or how to actually what if we actually meet with such an error, the program actually breaks and the execution of the code stops. So that is where error handling comes into play. We need to understand how to actually handle these errors. So for this we use the try except block. You might have seen this thing. So we'll say try. So we'll say a is equal to 5 divided by 0. So normally this would actually raise an error here. So this would raise a 0 division error, because actually we cannot divide a number by 0. So yeah, this is one such exception, just like the other exceptions we discussed before. So this is the 0 division error. So now what we are going to do is we'll actually put this inside a try block. So I'll say try, and now we'll just put this under this to make it correct to the syntax. So now we'll say except. So we need an except block. Now we'll say except we'll print, we can print something went wrong. So yeah, so what we are actually doing here is we are actually expecting an error here. We think that this thing can actually fail sometimes, or in this case this actually will fail. So sometimes a program may fail, or some functionality, or some part of the program may fail. So in such cases we use try and except blocks. So now if I just run this program, you can see that it's actually going to the except block. Now if I just change this to 1, and if I print a, now if I run this program, you can see that the except block didn't get executed because the try block was not a failure. It succeeded and no error was printed out. So if I just change it back to 0, now if I run the program, it is actually the 0 division error that is happening, but the execution did not stop because we use the try except block. Now we can actually execute things here. so we can say something, I don't know, maybe something. And if I run this, we can see that the execution did not stop, even though it was actually an error. It continued executing the rest of the program without actually minding that thing inside. So this is why we can actually use try except block. So if I just remove this except and try, and if you only actually have this code, so say I only have this code here, and now if I try to run this, this will actually be a zero division error, and whatever I execute after this, so if I say print something, and that will actually not get executed because the program execution is stopping here. That is why we can actually use try and execute or try and accept here. So now we can also accept a particular type of error. For example, here we will be getting zero division error, right? So we can only check for that particular error. So I'll say accept zero division error. So here only if the zero division error occurs, it will actually go to this block. So we are expecting a zero division error here. So if I run this program, we can see that something went wrong, or we can say here zero division error occurred, zero division or error occurred, or whatever you want. And if I run this, you can see that this code is still being executed. So we are actually expecting a particular error here. So that is what is happening here. So instead of printing our own custom messages, we can actually print what the error actually is. So I'll say accept zero division error as E, short form for error. So E here is just a variable, so I can just print E. So this will actually print the real error message, but the program will not stop. So it'll say division by zero. This is actually the message by the system. So you can actually add multiple exceptions here. So say for an example, I have a B variable here, and I am trying to add a number and a string. This will probably be a type error if I'm correct. So I'll say except type error. Yes, type error as T. This is another variable. So we'll print T. So yeah, let me just remove that error. Now if I run the program, you can see that we are getting the type error message, but the program execution has not stopped because this final code has been executed. So yeah, we can actually catch different errors, or we can use multiple except statement to catch different errors here. So we can also use an else statement here. So this means if everything goes well, just print me. So we'll say everything is fine. So now just remove this, and we'll add a 1 plus 1 here. And if I run this program, we get everything is fine. This means that none of the exceptions occurred, or no error occurred, and everything is fine. So we also have a finally statement. So this is a finally statement. So we also have a finally class. So this will get executed no matter whatever error you run into. So this is usually used for cleaning up actions. So finally will get executed no matter, even if an error occurs. So if I say print cleaning up or clean up or whatever you want, and I'm just removing this type error from here. So let's add a string with an n here. So this will naturally run into an error. So let's see what happens. So yeah, the finally has been executed. The program broke, or the program actually stopped, and this final something statement didn't get executed. The program actually broke here, but in this line it broke, but it still was able to print this cleanup. So even if an error occurs, you want to do something, then we have this finally statement. So that is why it is used for. So we can also create our own error messages or our own custom errors. So For that we have to say class and the name of the error you wish to create. So for example, I am actually declaring a variable here called a is equal to 100. So now I'll say if a is greater than, or if a is greater than 500, then it should raise an error. So for that I'm declaring an error here. So I'll say class value. So I have a variable here and a is equal to 100. So now I'll create an error class, saying class value to high error. So yeah, so this is a value to error, and it takes an argument inside called exception, the exception message that we should actually print along with the error. So and it'll say pass, and now you have created your own custom exception method. So now I'll say if a is less than, or if a is greater than 50, then it should raise the value to high error with a message inside called value to high. So now if I just run this program, yeah, it's actually raising the error called value to high with the value, with the statement that we said inside. So now let's catch it with the try exit block. So we'll say try, and now let's push it inside. Now we'll say except value to high error. We just print value to high. So now if I run this program, we get the message saying value to high. So this is how we can actually create custom errors. So you can create custom error messages for yourself using this method. So that's it about error handling in Python.